In Module 4, we will go to Chapter 4. We will start talking about how to make decisions. We will spend 2 weeks to talk about Chapter 4. So the first half, we will see how will we use the if-else statement. So you can see we move to the Chapter 4. In Chapter 4, the first half, we will talk about if statement. So this week, we will talk about if statement, and also we have if-else statement. If statement, actually you can combine with another if statement. So we will call that the nested if statement. So then we'll continue to talk about what is if, else if statement. I know there are so many if, you're confused about that, but don't worry about that. We will talk about one by one. But before that, you need to understand what is the relational operator. So the relational operator, that's using to compare number to determine relative order. So those operators, they are all binary. So when we say binary, that means you have two operands. We all see those kind of operators in algebra. So you know that's greater than, less than, greater equal, or less equal. So those operators, they are all binary. That means you have a value on the left and a value on the right. So we will compare the value on the left. Are they greater than the value on the right? So if that's true, we return true. If that's false, we return false. For example, I can show you. We try to see if 5 greater than 3. So this statement, if I show you, you say, oh yeah, that's true, right? Because 5 greater than 3. Right, so that's what we call the relational operator. You always have a value on the left. So then you have value on the right. So we just want to see if that's true. So if 5 greater than 3, right, that's true, right? So that's why we return true. Otherwise, for example, if I compare 3 greater than 5, so is that true? No, it's false, right? So that's why we return false. So the example here we show you, we say that's greater than, less than, greater or equal. That's all the operator. So they have a value associated on the left and the right. So we just read the statement to see they are true or false. So in math, we also including the greater equal. But in the programming assignment, make sure if you want to say greater equal, you always have the greater first, then equal. So that's why if you write equal, greater, this one is wrong. So that's why you see I cross out. So on the other hand, you see we can check 3 greater equal to 5 or not. So that's not true, so we return false. So on the other hand, we can check if 3 less than equal to, so that means less than 5 or equal to 5. So that's correct, so we return true. And also besides you have greater equal or greater less than or greater equal or less than equal, we have the equal equal. So this equal equal, you need to be careful. That means we are comparing these two values. You see before we can do one equal, right? So we assign the value. But now when you do double equal, so the double equal, actually we just check the value on the left, are they equal to the value on the right? So the same thing, 3 equal to 5, that's false, so we return false. And also the last one, we have not equal to. So the same thing, not equal, you need to have the not first, so that's exclamation mark. So then we have equal. So for example, we can check 3 not equal to 5. So you see this statement is true, so we return true. So this we say the relational operator. So those relational operators, if they associate with value, so that's why we call they are Boolean expression. They either return true or false. So for example, earlier we showed you, right? You see here is the operator. So 12 greater than 5 is true. So then we return true. So the same thing, 7 less than equal to 5. That's false, right? So we return false. So then sometimes you can compare two literal value, or we can have the variable. So we can see x equal to 10 or not. So of course, x is a variable. We just assume the x contain 10. Okay, so they associate with a value. So then since x is 10, so 10 equal to 10, right? That's true. So then x not equal to 8. We need to know x equal to 10. So not equal, so that's true. Or x equal to 8. So that's the Boolean expression. So they either return true or false. So after we're using the relational operator, we also can have that result to assign to a variable. For example, I have the variable x and y defined and assign the value. I can compare x less than or equal to y. So this one, they will return either true or false. So this result we will assign to the another variable. So this result, sometimes when we say if x less than equal to y, this one is true. So then they will assign 1 to the result. If that false, we will return 0 to the result. So then we will try to see, can we do that, for example. Let's create a chapter 4 example 0.cpp file. So we include IOString because I need to display something using namespace. So like earlier we say, we can try to see, can we assign a value after the rational expression. So then you see here, x equal to 10, y equal to 20. So then we just declare the result variable. So then we can try to assign result equal, okay? So this equal actually is from the x compare y. So sometimes we write like this, but sometimes if you kind of confused, I don't know what this one mean, right? So to help you to understand, you can also put the parentheses. So because remember, whenever we try to using the assignment operator, we assign the value to on the right to the left. So that's why here, even earlier, we don't have the parentheses. They still do this one first. So they will check x less than equal to y or not. So then we assign the value. So then you see we display the result in the console, or we see what we will get. So we run the program. So you see here, result is 1. So the reason is, you see x is 10, y is 20. So 10 less than equal to 20 is true. So if that's true, usually when we assign to the int, so then we assign the y. But also if you want, we can assign the result since we will have the value here either true and false, right? So we can do is we can declare instead result is int, we can declare result is the bool. But the bool, even we say that's a bool function, but you see here we can run the result. The bool function, even we say they have the true and false, but when they save in the memory, if that's true, they still save is 1. So if that's false, we see here, since 10 is less than equal to 20 is correct, right? So how about we change the x, maybe we change become 100. So now you see if x is 100 compared to y is 20. So 100 is now less than equal to 20. So here we'll return false. So we see here if the result is false, what they'll display. Oh, so here, yeah, sorry, I touched that. Okay. So that's the x. Okay, so then we run the program. Okay, so then you will see the result actually is 0. So that's we see here, we have the Boolean operator, but sometimes the Boolean operator we need to assign to the value, then we can see the result. We can display on the console. So here is, you can also have the result So then you can compare to assign to the value. So you can try to run other value to see what is the display on the console. So while we talk about those relational expression, because those relational expression is important relating to the if statement. In the if statement, we use that a lot in the programming language. So the if statement we see here. The if statement actually allows the statements to be conditionally executed or skipped over. What does that mean? Because usually you use the if statement a lot in the regular life. You see, if now it's raining, you will take an umbrella with you. If it's cold outside, or we see the temperature every day. If the temperature is under 60, so maybe you need to have a long sleeve. So that's why you see a lot of the time we have the if is the condition. If something is true, then we do something. So that's the if statement. So if statement actually you can see if it is raining. So then you check outside, oh, the weather is raining, so that's true. Then you do something. So the same thing for the programming. Actually, in real life, you do that. Programming will do the same thing as well. So the programming actually if is we're using the diamond to display. That's an if statement. Actually, that's a condition. So this condition, if that's true, I do something. If it's cold outside, I wear a coat. If not, then I just do nothing, or I just skip to somewhere. So sometimes you can see the diamond actually just the if is the condition. So that's the if condition. The result either true or false. So sometimes if that's true, is that cold outside? You see, you will wear a coat, but also you will do more things. You wear a hat, you wear a glove. So they can be multiple things you will do. So in programming, the same thing. Sometimes if true, then you do one statement. But if you want to do multiple statements, yeah, we can do that too. So now simply let's show your if statement in programming language. So we have the if statement, that's a keyword. So we put the one space. Then usually, and also of course, we always have the parentheses. So this parenthesis actually contain an expression. What kind of expression? It's a logical expression, like earlier we showed you. They may be compare x equal to y or x equal less than y. So then if this expression is true, then I right away execute the statement. But if this expression is false, so the statement here will be skipped. So that's the important thing for the if statement. So that's why we quickly show you the next example. We will have an average for the student's grade. If the student's grade is over 95%, that's an A+. So then you can download the same thing. That's our chapter 4 example 1. So then you see here, let's make a constant number. High score is 95. So then you see we have score 1, score 2, score 3. That's our int test result. Then let's find the average. So we will ask the user to enter 3 score. Oh, did you see that's very similar? Actually, that's your lab exercise 3. So then you've calculate the average. You calculate the average, you need to add together for the 3 scored. So because that's int. So when we divide, we need to divide by 3.0 to make average become double. So you see we display set precision 1, the average is something. So 1 decimal place. So now good. So this one is you didn't do in your lab exercise 3. So we continue. We check. If the average is greater than 95, you see here is our high score. Congratulations. So if that's greater than 95, so they will display congratulations, you got A+. So here you will see that's if statement. So if not greater than 95, so you see this one won't display. So I want you to you run this program yourself. And here we have the sample output. So if you enter 80, 90, 88, the average is 86. You see, nothing display. But if over 90